I'm sure most of you are familiar with the situation when you walk into a room and then you stare into the wall and then you think, why did I walk into this room? So you had a plan, right? Just a few seconds ago, you had a plan of what to do next, but somehow you lost it. So there's a special kind of memory that's supposed to keep plans like that in mind, and it's called working memory. It's a very useful kind of memory. You use it not only to remember plans and instructions, but you also use it to keep in mind relevant information when you solve problems. So it's very important for mathematical problem solving. And it is also closely related to attention. So one way to put that is you need to remember what to focus on. So I'm going to illustrate that by testing your working memory here. So your task here is to remember where this person is pointing so that you can point at the same boxes in the same order, okay? Okay, so now you're keeping information in working memory, 4 positions, so that you can do something based on that information, right? Easy enough. Let's have another one. So the same task, remember where this person points. Any volunteers here on the first row? So that's a bit harder. So this illustrates the key problem here. And the key problem is that working memory is limited. The capacity to store information is limited. And if I were to test you, you would remember roughly 7 items here. And this has been termed the magic number 7. And it's thought to be a very important limit on information processing ability of the human brain. But some of you might remember 8, some of you might remember only 6, so that's normal. But when you get an unusually low working memory, you run into problems. So children with low working memory capacity, they have problems remembering instructions, what to do next. They are inattentive, they fail in mathematics, they struggle with reading comprehension. So I said we had a problem, and I think I have a partial, at least, solution. So I started to study the neuroscience of working memory about 20 years ago to understand what's the neural basis for working memory and what's the neural basis for these capacity limitations. And one finding from our and others' research is that this is not a global problem all over the brain, but it seems to be restricted to a set of bottleneck areas in the brain and the connections between them. So here seems to be the processing ability of these regions is also constituting the limitations of working memory. But on the other hand, we know that the brain is plastic. It can change with training. It can change with experience. For example, if you look at musicians, violinists, you see the brain areas controlling the fingers. They change as a result of practice. So why wouldn't you be able to change these regions as well? So I teamed up with some computer game programmers to make a computer program where children could train working memory. So we want them to train on tasks similar to the one that I showed you here. To do that for at least 45 minutes. That's about how long time they can manage. And do that 5 times a week for 5 weeks. That's again about as long as they could manage to do this. Using computer game-like design made it slightly more motivating. We also could use the computer program to adapt the difficulty level, so it's close to the capacity limit. So that's a similar principle to when you do physical training. It's when you're close to your limits that you can actually change. Then we wanted to test the effect of this, and we did that in roughly the same way you go about when you want to try out a new drug. You have people randomized to either receiving the treatment, which is the working memory training in this study, or a placebo, which was a computer program where difficulty level was not adapted to the limit of the subjects. And then you have psychological tests measuring working memory capacity of the children before and after. So this was a very simplistic idea. This was a neuroscientist stumbling into the field of working memory and treating working memory as a muscle rather than as a magical black box. But it worked. So when we looked at the test results, we could see that children doing the training, they had actually improved the working memory capacity by roughly 20 to 15%. And this has been replicated many times now. So the magic number 7 isn't so magic after all. Then we went back to the neuroscience to look at what's happening in the brains of these subjects. And we could see that there are changes in these network regions or bottleneck areas. And other people have also shown that you can measure strengthening of connectivity between these regions as a result of working memory training. So we could show that indeed the brain is plastic. So this is nice. We can push the limits. We can watch the changes that's happening in the brain. The third question is, does it matter? Does it matter for people in everyday life? One thing that does matter is remembering plans and instructions. And we and others have now actually measured how long instructions can a child keep in mind and perform accurately. And does it change? And it does. So children going through the working memory training, they can now remember longer instructions. Another way to look at usefulness is actually asking parents and teachers about symptoms in everyday life, the behavior of the children in everyday life, about inattentiveness and if they can follow instructions. And here we're looking at 13 studies that did that. So they get inattentive symptoms in the group doing the training and how that changes, and in the control group and how that changes, and then comparing them. If there was no effect at all, you would see a little green dot precisely at the line here. But as you see, the green dots, they end up consistently to the left, meaning here that you have a reduction of inattention in the training group. And if you add this up, you can see that this reduction is around half a standard deviation, which is pretty good. So we published the first working memory training study 12 years ago. Now there are more than 100 studies published on different aspects of working memory training. And we will continue to learn about how to do working memory training, what's the most effective way to do this. But we already see that there is an effect that is useful in practice. And now we have more than 50,000 children that has benefited from working memory training in more than 20 different countries. So the science tells us about the effects, but it's also interesting to hear from the children. And here are some comments. So one says that now I can remember what the teacher says. Another, before I couldn't find my stuff, I could be looking for 2 days. Now I can find them at once. Or I can sit and shut out the noise from around. When I read, I can focus. Before, I couldn't do that. So this training does not solve all the problems that these children might have, but it helps them keep focus. It helps them keeping a plan in mind. And that's a good start. Thank you.